Okie dokie. So this is one of a series of problems where you've got some sort of a bug or whatever, or something that's trying to make its way around some three-dimensional object in the quickest way possible. Right? So, how are we going to get there? Well, the trick here is to turn this from a three-dimensional object into a two-dimensional object, since the bug has to travel around on the surface. So we break the cube down into what's called a net of the cube. Right, so it's the cube sort of flattened out, like a box flattened out. And then we just have to figure out where all the points are, F, E, H, G, A, B, C, D, or whatever, and place them on here. And then the shortest path from F to D or whatever is going to be along a straight line between those 2 points. Unless, of course, I suppose you put F here and then like D is down here, and the straight line takes you outside the net. I couldn't travel like shoop down there right off an empty space. Now, of course, this isn't the only way that you could take this box and flatten it out into a net. There are a variety of different ways to do it, and that could mean that there are different ways to get from F to D, different paths around the box. So let's see if you can figure some of those out. By the way, I will tell you what, here's an extra credit thing for you, which by the time you see this, I will have probably forgotten that I offered this up, so you'll have to remind me of it. But there is a way I can flatten out a box that doesn't have a top. All right, so just like this. All right, here's an example of one. Okay. So here is a box. Right, it doesn't have a top. I just fold the sides up. Okay? So 2 questions. 1, how many different ways are there that you can fold up, that you can flatten out this box? So how many ways could I cut the box up and flatten it out to make this net of an open box? By the way, and then the other more general question, if I just have 5, because there's 1, 2, 3, 4, 5 squares, and I want to put those 5 squares together, right, into what's called I won't tell you the name of it, right? I'm just taking 5 squares and placing them together. And the rules are, for this, well, the goal is to figure out how many different ways there are to do it. This is one option, it's this open box. There are lots of different ways to do it. The goal is to figure out how many there are. And the rules are, I can place the squares anywhere I want, but they have to all be connected. They have to be connected full side to full side. So, for example, I have this sort of connection. Right? If that's the only thing connecting those 2 boxes, that's not allowed. Can't do that. Right? I mean, these 2 boxes are connected in that way, but that's not the only way, the only connection that the box has. There's another box here. Also, you can't do something like this. Right? It couldn't be like that. Right? This little brick-like shape. That's a no as well. Right? So full side to full side. So the question is, I have 5 boxes, all connected, so that every 2 boxes is connected by a full side to full side. How many different ways are there to do it? So that's one of them. Here's another one, for example. There's 1, 2, 3, 4, 5. There's a second one. 1, 2, 3, 4, 5 boxes. Okay. So how many of them altogether are there? And which ones can be folded up, like this one can, into a box with no top?